G'day. So I'm just rearranging my keyboard synth and stuff, putting it into another room. I haven't used these monitors for a while. I discovered one of them has a horrible noise when you turn it on. These are just audio line, apparently biamp monitors. The lights come on and it immediately does that, which is pretty horrible. I do still get audio out of it, but not very high level. And so that's what they are. Got an unbalanced input, two balanced inputs, level controls, a bit of compensation if you want some high frequency adjust. And they're just a ALSM 50s, so I think that means they're a 50 watt amp. So now I'm going to pull it apart and see what the problem is. So I've taken out the screws, which is just around the outside of it. It's a bunch of self-tappers. It's a fairly solid board, so let's pull it forward and see what we can see. It looks like normal linear power supply because of the transformer input stuff. It looks like it's probably the power supply stuff and the amp on the one section. Input stage seems to be shielded. Nice heatsink. So let's have a closer look at the board, see if we can see anything. Well, looking at the bottom of the board, there's nothing obvious burnt there. I'm kind of hoping that it's a just some caps have dried up or something. It does run fairly warm, so it might be a bit of a trick. There's a bit of corrosion and stuff on the board, but that I think has been there the whole time. So I'll undo the screw on the supply and see if we can see something on the other side. I'll identify where the power supply rails in then are, and then we can stick a crow on it and see what it's doing. So the AC on this comes in from the transformer. See those four wires, that's the secondary. The primary is over here, goes off to the main socket. So it comes in on there and goes off, and there's a bridge rectifier under there, which you can just see there. And then there's a cap across the bridge rectifier. That's this electrode. And it says it's 25 volts, so therefore the voltage on that can't be any more than 25 volts. So I might stick the multimeter on that and see what we get. Just to give me a rough idea of what the voltages might be, and then we'll stick the crow across the cap as well and see what it looks like. It should be relatively smooth with very little load on it. If the bridge has perhaps failed and that's why we're getting the noise or something similar, that could be it. It'd be interesting to see on the crow what frequency that noise is that's coming out of the speakers as well. See whether it's related to the mains. So this first supply is, you can hear that noise, 34.6 volts on there. And the second one, because there are two supply rails, that's interesting, it's just gone away. This is really hard to do with one hand without stuffing everything up. That's the other rail. And that one is 47 volts. So a reasonable amount of juice. So I should probably put the crow on there, although it's a bit of a worry because something's warmed up and now that noise has gone away, so it'll take a bit more looking. So I've stuck the ground of the crow on the negative terminal of this bridge rectifier, and we'll put the other one on the positive, and that's with no audio. You might just be able to hear a bit of hum there. If we look at the crow, we've got, that's 20 volts per division, so we've got about 40 volts, but there's 20 volts of hum on there. If I'll take that back off, that's our ground reference. That's the other side. So I reckon that might be a bridge rectifier fault. So I should probably pop that out. Either that or the caps are really bad, but that really just, I think, looks like a bridge rectifier. And I did check the other one, and it was quite smooth. So because it's all really hard to hold, I won't show you that on this one. Let's pop that out. Okay, so I took the bridge rectifier out. That's it there. And I've gaffer taped the phone to my work light so I can have two hands on things. So if this suddenly lets go and the image goes A over T, you know what's gone wrong. So on the diode test range and checking on the bridge rectifier, so we'll check from the AC input pins. Nothing that way, which is what we expect. Nothing that way. Reverse the polarity. Going from the AC input to the positive on that side. Yep, conductivity there, which is right. And we've got no conductivity there or there. But when we go in the negative on that output, oh, did I just get that wrong? That almost seems like I've got an intermittent in the bridge. No, that works. So we should have conductivity there because... No, stuffed that up, didn't I? Wrong way around. So that works that way. And the other way around to there it works, and there it works. So therefore the bridge appears to be alright. So maybe it's the caps in that area of the board. If I try and drag this over here a bit, which I can't because I run out of reach. No, have to wait another shot. So if we're seeing as much hum as we were, but the bridge rectifier that we just tested was okay, and really maybe I should be looking at these caps. If it's dried right out, I guess we could be seeing that amount of hum, but I honestly don't remember what shape the output of the bridge rectifier should be. It's been so long, so many years, but I guess I'll try that. I can always pop a cap out. I've got a bunch of large electrodes and we'll see what happens with that. So I'll unsolder that and we'll see. So if we do that, I reckon we can just using a normal little solder sucker. Find the right pins. This takes a reasonable amount of heat because the actually, no, I thought that was a dry joint. So if we get that melted, often helps to drop some more solder on there. This helps melt what was already there. And get the sucker in. Does a reasonable job. These things are neat, they make a bit of a mess if you just drop the stuff on the floor like that, which is what I tend to do. Get some more heat in it. The same on the other side. You want to make sure the caps are discharged when you do this, because if it's referenced to ground and you've got the thing connected to anything else, then sticking the soldering iron on there could discharge the cap to ground. This happens to be unplugged, so I know it's going to be alright, but also you don't want to get sticking your fingers across the caps if they've still got a charge in them. I could use some solder wick on that, but I won't. Just the leads are really short, so it's free. I should probably put a bigger tip in the iron, but I think that's going to come out. Yeah, it doesn't look very flash, does it? Looks like it's had a little squirt out the side. Unless that was just some adhesive, but the pattern looks a little funny. So I think we'll stick that on the meter and see what it does, if we can get the meter to indicate that it's charging. So I thought that cap looked a bit crook. If you look in here at this, the cap right next to it, that really has all spewed out of the capacitor. The top is deformed. If you can see there on that shot how it's bulged out and it's spewed all its contents everywhere. So that would explain it. And that's the electrolyte that was in the capacitor. Just spewed all over the board. So I think I should probably take that one out. And there's a fair chance that's the problem, because that's disgusting. Let's see what happens if we take that one out. Bit more heat. I should turn the iron up, shouldn't I? I'll throw some more solder on sometimes. I get the solder on there to get the solder off there. It's better. See if I can wriggle that loose from the other side. That electrolyte is really stuck to the board. If anybody else was doing this and I was watching them, I'd be telling them to, it's better. Put a bigger tip in the iron. Even the multimeter's bored. Right, so let's have a look. Yeah, that's sick, isn't it? Very bulged and nasty looking, so I reckon you should replace those and we'll see what we get. What are they? 3300 at 25 volt each. So let's see if I've got some or something similar. So I had a look, but I didn't have any of these particular value and size caps. These 3300 25 volt ones. What I did find was these 47s at 50 volts. And so more voltage doesn't matter, more capacitance is good, because you end up with smoother DC. So I've hung those off fly leads just to give it a test. But you know what happens if you test it with something like this and you discover it works, you tend to just leave it in there. But I might go down to Jaycar tomorrow and see if they've got a couple of the correct ones. But I've got it plugged into the old Electronics Australia function generator on the unbalanced input. And that works. And no sign of hum. So I reckon I'm going to call that fixed. Awesome. I'm beginning to enjoy fixing things. See you later. And finally, just to prove it does work, there's one on my FA08 workstation. The other one's down on the floor because I'm just moving the stuff into this room. It's got a TV on the wall and have the keyboard, maybe another one above it. But if we hit something that was recorded earlier on the keyboard,